Alright, so in this clip we'll talk about the particle collision event editor. So let's first create the simple emitter with the create emitter, and let's say we have the emitter type to the omni. Let me reduce the rate to the 20 only, increase the speed value to the 3 with the random speed to the 2, and hit the option create. Let's reposition this and select the particle shape node, change the color to maybe red, and also change the particle render type to the sphere. And let's also enable the ground plane so that particle can collide with the imaginary ground plane. That's perfect. Increase the time slider, no problem, and here we go. So now let's talk about the particle collision event editor. Well, as the name goes, it says its own. The particle collision event editor simply means that once the particle collides with the passive collider, then it generates an event which has two types, either emit or a split. In simple word, it helps you in emitting the secondary particles the moment the first particle collide with the passive collider. Alright, so let's do one thing. Let's first have a passive collider. We have a simple sphere. Let me just increase this. Alright, put it over here and go inside the enclosed menu, and here we have create passive collider, and make sure that both of them are having the same nucleus. Hit the option make collide. Now once you play the timeline, you can notice the moment particle reacts with this, they are simply sliding, and now the particles are basically getting collide with the sphere. So let's also increase this a little bit, no problem. Okay, so let's do one thing. Let's go inside the nParticle's and go for the particle collision event editor, and it's already showing the objects, which is nParticle1 and nRigid1. We'll go for the nParticle1, and over here we have the event type. It is saying the type or the split. There is a big difference between the emit and the split, and I'll tell you theoretically, but I also show you the practical usage or the practical difference between the emit and the split. Let's first talk about the emit. The emit event type will generate the secondary particles by creating new and fresh particles, which means the moment the secondary particle born, they'll have their age set to the 0. However, in case of the split, whatsoever is the age of the parent, the secondary particles will adapt or inherit the age from their parent particles. We'll take a look at this a little later. Alright, so let's first concentrate on the emit. So here we have the type, the event type set to the emit, and we have the number of particles. Right now it's 1. Let me have 4 particles for every 1 single collisions. Spread is set to, let's say, 1. So if you just want your particles to move away from the the primary ones. And inherent velocity simply means that it will follow the velocities of the parents. And target particle will be the one which will get created the moment we create the create event. Alright, here we go. Here we have the target particle, which is nParticle2, and the moment you hit the option create event, it has given you with the result event 0 has been created. Alright, now let's close this, and in the nParticle2, go inside the shape mode, change the type to the sphere, and change the color to the green. Let's also decrease the size, maybe 0.1. Alright, now let's play the timeline, and there we go, no problem. You can see the moment the red particles are hitting this passive collider, the green particles are getting generated. But there's a problem. If you just notice, the moment the red particle clicks, it just disappears and the green particle appears. Well, this is maybe because of the option that we are using, which means original particle dies. So this is also a big difference between the emit and the split. So if you go for the split, you can notice you don't have the access to the original particle dies attribute. However, if you are working on the emit only, you can disable this. Now you notice that the red particles will not die the moment it collides with this passive collider. They will remain throughout the scene, and this is something great, you can see. And as far as the the red particle are in contact with the passive collider during the time of their sliding or the time they collide, they'll consistently emit the secondary particles. Because I tell you one more interesting thing, these red particles are also carrying their event. So the more they collide with the passive collider, the more event they'll generate. Let's configure where exactly is the event. Well, you can go inside the particle render type, check to the numeric, and over here you can just type the event. So the moment you click this, you can notice some of the particles are showing the event type 0. This is just because they still haven't collided with the passive collider, whereas some of the particles have already collided. So let's say this particular particle has collided 2 times, whereas the other particles, they have collided 3 times, and there are other particles which have collided for 10 times. So if we roll back the timeline and I play, you can notice right now the event is a 0. So let's do one thing, let's bring them frame by frame, and here we go. So notice for the value 2, it means it has collided 2 times. Just keep playing and you notice that now it is actually sliding, and this is also accountable in case of the collisions. So that's pretty much nice. Now let's do one thing, let's change them back to the sphere. Now let's talk about the split. Well, there's another interesting thing that I can tell you so that we can easily able to distinguish between the emit and the split. Let's do one thing. Let's select the nParticle 2, go over here, pick the type numeric, and change the age. Now it simply means that once the red particle collides, the moment the green particle creates, we can see their age. So go with frame by frame, and there we go. 0, which means the nParticle 2 has just born. And if you just keep playing, you can see the moment you increase the frames, the age is also getting increased. Alright, but the point which you are required to consider is that the moment the red particle hit the passive collider, a new event generates, obviously with the help of which the green particles also emitted, but the green particles have their age set to the 0. Now if we change the type, the particle collision event editor, from emit to the split, now you notice the split particles, which is nParticle 2, they will inherit the age of the red particles. Now let's do one thing, let's play it slowly and notice this is actually the very big change. So right now we have, it's basically the green particle over here, and the green particle is showing you the age of 1.629. This is just because it has inherited the age from the parent. Let's do one thing, let's select the red particles and put the age, and right now if you notice carefully, it is 1.503. Now if I select the nParticle 2, or let's say we select this one and keep playing, now this is nParticle 2. Now your first particle just dies out because it has collided with the passive collider, and the moment it dies, another particle, which is the green particle, just emerged because of the collision, and it has inherited the age of the parent particles. So that's basically the big difference between the emit and the split. Alright, now let me also just show you one limitation which is really very important to be considered. So what if I just want my particles to collide with only one passive collider, or let's say it should collide with 2 passive collider, but the secondary particle emission should take place only from the bigger one. Well, that cannot be possible due to the limitations of the particle collision event editor, because the particle collision event editor just considered the collision events. If I want the emission of the secondary particles only from the bigger passive collider, that wouldn't be possible. So now if I play the timeline, you can see still the moment it collides with the smaller one, the green particles are coming. So my question was, the red particles are required to collide with the smaller passive collider, but the emission of the green particle should take place only with this bigger passive collider. So this is basically the current limitations while using the particle collision event editor. You simply just cannot control your collisions based upon your own passive collider. So what if I just want that this particular passive collider should emit the green particles, and if there are 4 to 5 objects, 4 to 5 passive collision objects in our scene, but we want the secondary emission of the particles only with the particular one. It cannot be just possible while using the limited particle collision event editor. Alright, so let's do one thing. Let's fix this problem in the next clip, and we'll talk about the emit command. So let's get started with that one.